Assalamualaikum warahmatullahi wabarakatuh and good day everyone. So today we will continue our lesson on Introductions to Scientific Programming, which is chapter 5 related to the MATLAB functions. So without further ado, let us proceed. Right, so before we proceed with our lesson, let's take a look at the objective for today's lesson. Right, so the first objective is to create function. So today you will learn how you can create and use Mfile functions with both single and multiple inputs and outputs. So in MATLAB, if you wanted to create a functions, we can create a function either you wanted it to be a single input or single outputs or multiple inputs and multiple outputs. Alright? So the second part of the objective is to create and use local function and nested functions. So in MATLAB, we have main functions, local function, and nested functions. And all of those functions you will learn towards this session. Right, the second objective is a variable scope. So you will be able to understand the difference between base and function workspace and how you wanted to differentiate between both of them. And the second part of the objective is understand the variable scope of command window, script, main function, local function, and nested function, and when or where you can access those variables. And the last part of objective for today's lesson is Toolbox. So the third part of the objective is you will learn how you can create a toolbox from your functions or from your codings or from your Simulink files. Right. So let us proceed with the lesson. Okay, so right now we recap back on our lesson on operations in MATLAB. So MATLAB operations start with a statement, okay, where the first part of the statement is assignment, where we give some data to our variables. Alright, either it is arithmetic or Boolean. And then last week we already learned about repetition and decision, where you learn about while and for loop, and also if else and if else if, and also switch case. So today you will learn about functions, which is a group of statements. So if you have some statements, you can group it and you can call it a function. And today you will also learn some of the commands that are available inside MATLAB. Alright, so in MATLAB functions, what is actually a function? So in MATLAB, we have a program file. So program file is actually a .m file that contains a program. Right, so last week we already learned about the script, how we wanted to create a script. And after we create a script, we will produce one file, we call it .m file. So inside the .m file, it contains a program. Right? So in program, there are two types of program files. First part is the script file. Alright, so the things that we done last week is a script file. So in script file, it contains sequence of commands, function calls, and followed by local functions is needed. So in script file, you can initialize your variables, you can call your functions if you have any functions, and you can also have some local function inside your script file. And the second types of program file, we call it a function file. So in function file, it can only contain functions. It cannot contain any other things. Alright, it cannot contain a sequence of commands. Okay, it can actually it can contain a sequence of command, but the base of the function file is a function. It must start with the function and it must end with the output. So what is functions? So function is actually a program that accepts inputs and return outputs, right? So in function, you must have inputs and you must have outputs because you need to return the outputs from the inputs, okay? You accept the input from, for example, from the script file, all right? And then you process it and you return the output from your function, okay? So that is type of, that is the definition of a function. All right, why we use functions? Alright, so actually when we going towards the coding, our coding can become long and it is hard for us to diagnose or for us to debug our code. So if we use function, it is actually like a sub-program that can make our code cleaner, okay? And then the second point is it can be easily for us to maintain, right? Because we have been organized our codes differently, and our lines of code is not too long because we organize it in terms of functions. And the last one is reuse. So it is if we have any functions, if we create a function, we can reuse it in another application as long as we know what is the name of the function and what is the usage of the function. And the last one is hiding implementation. So if you are a programmer who wanted to hide some implementation from the user because you don't want user to duplicate your work and so on, you can hide it by using function. Alright, next, what is function versus script? What are the differences between function and script? Alright, so the first criteria that we will take a look is in terms of usage, right? So that is similarity. So this is the similarity between script and functions because both script and function allow you to reuse sequences of commands by storing them in program files. So both script and function, we can use sequences of commands, right? And it will be stored in program files. Right, the second criteria is the program. So in script, your program must have a fixed variable. So you cannot change the variable in your script. But in function, it is more flexible and easily extensible program. Right, so function is actually when you call a function, you give the input value. Right, so if you don't want that kind of input value, you can change it simply like that. Okay, so that is the differences between function and script. And then input output. So script doesn't have input and output, but function has an input and output. Because later on when you learn on how you wanted to write a functions, you must have input and you must have output. Alright? And the last one is the criteria is in terms of workspace. So script variable is saved in base workspace, which is the workspace that we can see inside our MATLAB. But the function is the variable or the data saved inside the function is saved inside the function workspace. So you cannot see the data inside your function. Alright. Next is the types of functions. So the first type of function is predefined MATLAB functions. So in predefined MATLAB functions, first we have a built-in functions, which is the code is not accessible to user. Okay. Predefined MATLAB function is the function that MATLAB has already created for you. You can just use it, right? So in predefined MATLAB function, we call it built-in function where you cannot change the codes. And also we have a Mfile function where the code is accessible to user. So you can see what the code does inside Mfile function. But both this function has been predefined by MATLAB. Right, so later on we can see, I will show you some of the example of predefined MATLAB function. Right, so the next type of function is user-defined function, which is the function that you created by yourself. Right, so you can create a Mfile function, you can create an Mfile functions, and you can create a local functions, and you can also create a nested function. Okay, so all of these three functions we will learn it towards this lesson. So in addition to those three user-defined function, we also have anonymous functions and we also have a private function. But those two user-defined function, these two, it will not cover into this lesson. We are not covering this one, right? Okay. So next, let us proceed with the predefined MATLAB function. Right. So let's take a look at the first example. So this is the first example of the predefined MATLAB function where MATLAB has defined this function, has created this function. What you will do is you just need to use it, alright? Right, so in MATLAB, if you use sine, you can type it sine, type sine, and then it will show that sine is a built-in functions. So it means that the built-in functions, it is predefined by MATLAB, but you cannot access or you cannot see the codes behind this function. Alright, so that is predefined MATLAB function, which is built-in. Right, so example number 2, you can type sphere. All right. So sphere is actually a predefined MATLAB function, but we call it Mfile because we can see the codes behind those functions, right? So the sphere function is stored as a function Mfile, but is provided by MATLAB. Okay, you can see the coding behind the function sphere, which has been predefined by MATLAB, right? Because we call it Mfile, because we can see the codes. This is built-in because we cannot see the codes behind the function sign, right? So studying this function may help you understand how to program better function yourself. Right, so when you are going to take a look at this type of functions, so you can study by yourself, right? So how you can create a functions. All right, so that is the example of the predefined MATLAB functions. So now let's take a look at the user-defined function. All right, so the first type of user-defined function is the Mfile functions. So what is actually Mfile functions? So user-defined functions are stored as separate Mfiles. So once it is created, it is available in the command window and MATLAB script. So once you create your function, it will be available in the command window and MATLAB script. So to use them, they must be in the current directory. So if you wanted to use your function, you must go to the current directory of your functions, okay? So that you can access your Mfile functions. Right, so this is the example of the, the template of the how you can write an Mfile functions, right? Where the syntax is functions, and then you have output variables here. If you have multiple outputs, you need to put it in the square bracket, and you separate it by using a comma. Okay, so this is your output variables equals to. So this is your function name. Right now, your function name is myFun, right? And next, this is your input variables, right? So your function accept how many variables? Okay, so for the input variables, you need to put it inside the normal bracket and separate it by using comma, right? And then you can proceed with your statement, okay? But before you end your function, you must show what are the equation of your output. For example, y1 equals to what, yn equals to what before you end your function. So that is because you wanted to return the value of your function. Alright, so next, how to create Mfile function. So let's take a look at example number 3. Right, so in this example, it will show you how you wanted to create a function called polyx. Okay, right. So the function name must be the same as the file name. So you need to make sure that this is your function name. All right. So the name of your function must be the same name as your function file. So as you can see here, your function name is poly and your file name is poly.m. Okay. So the input argument is written inside a bracket after the function name, right? So you receive one input, which is x here, and output argument is written before the equal symbol. Okay, so this is your output argument. This is your output name, and this is your output argument. Okay, output equals to 3x power of 3, 5x power of 2, and minus 2x plus 1. So this is the polynomial expression. Okay, so before you end your function, you must define what is your output. Right. So if you execute this function, you will get the answer of 121. Okay. Right. So next, add help to the program. Okay. So previously we are doing the polynomial expression. Okay. Function, and then you can add help to the program by commenting the line after you initialize your function. So as you can see here, your function output is named as output, and your function name is g. The input of your function is x and y. Okay, and then you comment after your function's initialization, and it can function as help. Okay, it means that it can define and you can describe what your function is all about. Okay, and then you initialize your output, and you will get your this is the expression of your functions. And then when you write help and then following with your function name, it will show the description or the help of your program. Okay. All right, let's take a look on how you can create a functions. Right, so to create a function, this is your MATLAB interface, all right? And first you need to go to the new script, okay? And then we can create a function by using the first example, okay? I will show you the first example, which is a polynomial, okay? Right, so first and foremost, you need to put a syntax function, and your output. You can rename your output as what you call as any names is possible, okay? Equals to poly, which is the name of your, this is the name of your function, and input x, okay? Right, and then the second line is you can give some help information, okay, some info on your function. So you can start with the percentage space, this function calculates the, okay, you can create another line so that it is easier for you to read, value of a third order polynomial, okay, and then you define the output equals to 3 multiplied by x to the power of 3 plus 5 multiplied by x to the power of 2 minus 2 multiplied by x plus 1. Okay, and then after you initialize or after you write your functions, you need to save it. Okay, you save, and you need to make sure that the name is similar with your function name. Your function name is poly, the name of your function must be also poly. You need to create save, and you can see here it has been renamed as poly. Alright, so if we wanted to run the function, you can do it as like this, x equals to poly 3, and you will get the answer x equals to 121. All right, and then if you wanted to know, so what is the function is all about, so you can just put help poly. Okay, so it will shows your help information. So poly is actually, this function calculates the value of a third order polynomial. Right? Okay, so that is how you can create a function, Mfile function, and you can add help to the program. Right, so next we will take a look on the multiple inputs. So what if your function has multiple inputs? So what you should do? Right, so previously we learned about a function with a single input and single output. Right, so right now we will learn about a function with multiple inputs. Right, so as usual, we put the syntax function here, and your output name equals to g. If you have multiple inputs, you can put it as x. You must separate it by using comma, x comma y, and then output you must use your input lah. Okay, output equals to x dot multiplied by y. Okay, so it means that it will multiply all of the elements inside x, and it will multiply all of the elements inside y. Okay, so if you have multiple inputs in a function, you must put it in a normal bracket and separate it by using comma. Okay, so that is multiple inputs. Alright, next is handling inputs. Right, so previously we initialize a function g, we call it function g, with two inputs of x and y. So our inputs, we have two, okay? And then when we call our function, we call it as x equals to, we call function g, but we give only one input, right? So the function has two inputs, but we only give one input. So MATLAB will return an error because it has not enough input arguments. So your input is not enough. Okay, so for MATLAB, if the function has two inputs, when you call the function, you must also give two inputs. You cannot give less or you cannot give more. Right? So since line 4 needs 2 inputs, executing the function returned an error of not enough input argument. So to create a flexible input or a function that accepts any number of input arguments, you can initialize a variable called varigin, and nargin can be used to handle the inputs. Okay, so to solve this problem, you can use varigin and nargin. However, those advanced variable is not covered in this course. So if you wanted to do more detail, or if you wanted to know more details about varigin and nargin, you can refer to MATLAB documentation for detailed explanation, because we are not covering those extended or advanced variable in this course. All right, so you can go to the MATLAB documentation and you can study about that. All right. Okay, so next is multiple outputs. So what if your function has multiple outputs? So what you will do? Right, so let's take a look at example number 7, where our function has multiple outputs. Okay, our outputs is distance, velocity, and accelerations. So if your function have multiple outputs, you must put it inside a square bracket, and you must separate all of the outputs by using comma. Okay, and then your function name is motion, and your input you only have one, which is t. Okay, right, so this function calculate the distance, velocity, and acceleration of a car for a given value of time t, assuming all of the 3 parameters are initially 0. So this is basically calculate the distance, velocity, and acceleration with respect to time. Okay, right, so use square bracket and comma to create multiple outputs, so as I've been mentioning to you just now. And when using a function, different variable name is allowed. Okay, so when you are using a function, you can have different variable names. So it doesn't necessarily your output is what do we call output. Okay, you can do some variable name. Okay, so detailed discussion later in variable scope topic. Right, so if you wanted to initialize multiple outputs in MATLAB function, you must put it in square bracket, and you must separate it by using comma. So that is the information that you need to grab in this lesson. All right. Okay, next is the output flexibility. Okay, so now we initialize a timestamp where we initialize time from 0 to 0.5 second, for example, and the interval is 0.1. So 0, 0.1, 0.2, 0.3, 0.4, and 0.5. We initialize it by using colon operator. Okay, you already learned about this one in the second chapter or in the first chapter last time. Okay, and then we initialize a variable called distance, okay, equals to motion t. Okay, so if we initialize one output only, okay, and we call the function of motion and we give the input of t, it will return only distance. Okay, right, and then if we initialize a variable called distance comma velocity, okay, and we call a function of motion and we put t here, we put our input, and it will return to distance and velocity. Right, so if we take a look at the function output, we have 3, right? But we can call output less than 3. Okay, but we cannot call the output more than 3 lah. All right, so this is we call it only one output, we call only distance. Okay, all right, and then we call distance and velocity. All right, so you can just put any parameter here, any name here, for example a, b. So a will return distance, b will return velocity. All right, so if you don't ask for all output variable, the program returns the number of variable you ask starting from the left. Okay, right, so if you didn't ask for all variables, okay, so if you only ask one, you will get the distance only. If you ask 2, you will get distance and velocity. So if you ask all the variable, you will get distance, velocity, and acceleration. Okay, all right, so in example number 9, okay, as usual, we initialize the timestamp from 0 to 0.5 with the interval of 0.1. Okay, but we call only 2 output here. Okay, we name it as distance and acceleration. Okay, and we call it a function, right? And you will get those 2 data, right? If you need to return the last output variable, all of the preceding output variable need to be written as output. So in this example, a cell here is not acceleration but velocity, since the function return is at the second variable. Okay, so as you can see here, this is your function. This is the first output is distance, the second output is velocity, and the third output is acceleration. And then this is how you call the output. Okay, the first output you name it as distance, so it will give distance. But the second output you name it as acceleration as well. But this output, it will get the data from velocity, because in MATLAB function, if you have multiple outputs and if you didn't call all of the outputs, it will start calling from the left. Okay, distance will give to the IST here, velocity will give to acceleration here. Okay, all right, so you cannot call you cannot consider that output with the same name will call the function output with the same name. No, you cannot consider that. All right, so you must know, what you must know is that the first variable here refers to distance, the second variable here will refer to the velocity. But if you wanted to get the acceleration value, you need to add one more here. Okay, right, you need to add one more variable here, right? So distance, acceleration, or you need to add in the middle distance, velocity, comma, acceleration. Okay, so distance will be referred to the distance here, velocity will be referred to the velocity here, and acceleration will be referred to the acceleration here. Right, so if you wanted to call, or you wanted to get the acceleration data, you must call all the variables, or output variable, right, so that you can get the acceleration data. Right, so next is user-defined function, function with no input and output. So what if you initialize a function, but it doesn't have any input and output? So what will happen? So let's take a look at example number 10. Right, so function, okay, function, the square bracket because you don't have any output, and then your function name is stars, and in the normal bracket you don't have any argument or any input, because this function we have no input, we have no output, and you put the variable asterisk here equals to char, absolute, okay, star, right, once 1 to 10, you will create 10 stars. This what you call this function will create 10 stars, right? So you can also put it like this, function stars asterisk as usual, and display the asterisk. Okay, so you can put it in an empty bracket, or you can just ignore the bracket. All right, okay, so with a function with no input and output argument can be written with either empty bracket or no bracket at all. So you have two options, either you wanted to write it in empty bracket, or you can just ignore the bracket. Okay, this is the empty bracket and this is ignoring the empty bracket if your function doesn't have input and output. Right, so using the function can also be with or without the empty bracket. So alternatively, you can replace function with no input and output with simply a script file. So if your function, it doesn't have any input and output, all right, you can just replace it with a script file. You don't have to, you know, create a function, we call it star. So it is more complex when you are creating when you're just creating a script file. So script file, you don't have this one. In script file, you don't have to put function stars, but you just name your script file as stars, right? So it will be easier for you. Okay, all right, next is local functions. Okay, so what is actually local functions? Right, so local function is actually MATLAB program files can contain more than one function. Right, so recap, there are two types of program files as I've been mentioned in the earlier of this session, which is the first one is script files, the second one is a function file. Right, so local function can exist on both program files. So in local function, you can put it in script file and you can put it in function file. Okay, and local function is also known as sub-function. Okay, so you can also call local function as sub-function. All right, so next let's take a look at the differences between main and local function. Right, So the first criteria, all right, so the first criteria of main and local function is script file. So the script file in main function, it doesn't exist. Okay, we don't have any script file for main function. But for local function, we can have a local function inside script file, which is created after the last line of script code. Okay, after you initialize the variable, you can create a local function inside script file. Right, next is function file. So the main function is actually the first function inside the function file. But the local function inside function file is actually additional function. Alright? And in terms of accessibility, main function can be accessed by other function file and command window. Okay? So after you initialize a main function, you can call it anywhere you like. Okay? Either you want to call it in the command window, either you want to call it in the function file, other function file, you can do it, right? For main function. But for local function, it can only be accessed within the function file, right? So in your function file, you have local function, and you can only call the local function inside the function file, right? So after this, I will show you some of the example, right? Right. So in terms of function name, so if you initialize a main function, the main function name must be unique to all MATLAB functions. So you must ensure that your main function name is not similar to the built-in or predefined MATLAB functions. So if it is similar, you will get an error because MATLAB will be confused about that. Alright? So next is the function name of local function. It must be unique only within the function file. So if you have a function file and you have a local function over there, so you cannot have multiple local function with the same name. So that is the criteria for local function inside function file. Right. So before we proceed with the function file, so let me show you the differences between script file and function file. Right. So this is script file. For example, integer, for example, a equals to 5. Okay. B equals to 10. Right. C equals to 11. Okay. And then this is script file because we have a command which is in sequence. Okay. And then I wanted to initialize a local function. Right. So local function, you just put it function output. We just put it output. Okay. Equals to your function name is add. Okay. A, B, C. Okay. And then output equals to A plus B plus C. Okay. Right. So this is a example of the function, a local function inside, or what do we call, inside the script file. Okay. Add. Okay. Right. And then you can rename your script file as any names that you like. Okay. Right. So if you wanted to create a function file, so this is a script function. You can save it as addition. Okay. So this is a script function. And this is a local function inside a script function. So if you wanted to create a function file, you must start it with the function. Function output equals to add, okay, A, B, C, right? And output equals to A plus B plus C. Okay, right. So this is the function file where you need to rename your file, okay, as similar with the name of your function name. Okay, save. Okay, your function name is add, right? But this one, your function add here, but okay, but you don't have to rename it as add here because it is a local function inside script file. Okay, right. So local function in function file. So the syntax for local function in function file, first you must have a main function first. Okay, function, which is the main function. Okay, you can put any name. Okay, and then function, local function. It is like having multiple function in one function file. Okay, but the main, we call it main function because your name of your function file is the main, similar with the main file, with the main function name. Okay, right. So this is the example for local function inside function file. Okay, so your main function is function that returns two output at result and minus result, and your function name is compute. Okay, so your file, your M file must be renamed as compute.m. Okay, right. So this is the variable at result, and we call a function. We call it we call a local function at here, and we initialize another variable called minus result, and we call a local function minus here. And then you have another two function. Okay, those two function is called local function. This is a local function, and this is the main function, because main function is the one that your M file name is compute. Okay, so this is your local function inside a function file. Okay, your function will return result, and your function name is add, which is referred here, xy, and it will return. Okay, all right. So next is nested function. So previously you learned about function, a local function inside a function file, but this time you are learning about nested function. So what is actually a nested function? Nested function is actually a function that is contained within a parent function. Okay, so inside a parent function you have another function. So both main and local function in a program file can include a nested function. Okay, so if you have main function, or if you have local function, both function you can create a nested function. Okay, so since nested function reside within a function, end command is used to mark the end of the nested function and the parent function. Right, so recap, previously end command is not compulsory for both main and local function. So when we take a look at the example number 11, for main function, so this is main function and this is local function. Okay, so it is actually in sequence. It is not belongs to what they call the local function, not belongs to the main function. Right, so this is, we call it local function inside function file. But for nested function, we must have AND. Okay, so when we take a look at example 12, okay, so this is the parent function, we call it function. Okay, our output is circumference and area, and our function name is myCircle, and our input is D. Okay, this is the equations, right? And we can see here we have another function here, and we have another function here. Okay, and when we notice this is the function, and this is the end of the parent function here. Okay, this is the end of the parent function here. So it means that inside this parent we have another function. Okay, so in nested function you must have AND to indicate the end of, so to show that the nested function reside within the parent function. Okay, in the normal function you don't have AND, but in nested function you have AND here. Okay, so those two functions belongs to the myCircle. It means that Ci and AR functions, local functions, belongs to myCircle, because those two functions is located before the end of myCircle function. All right, so basically the theory is like that. All right, okay, next we will take a look at the variable scope. So what are the scope of our variable? Okay, when or where we can access our variable? Right, first is base and function workspace. So you must know what is base and what is function workspace. Right, base workspace store variables that you create at the command line. So this includes any variable that script create, and stored variable are shown in the MATLAB workspace window. Okay, so when we take a look at MATLAB, okay, so we clear the first CLC, right? So we clear all, to clear all variable inside workspace, okay? Right, so for example, we initialize A equals to 5, B equals to 10, C equals to 12. Right, so this is actually base workspace, which is the workspace that store variable that we create at the command window. So this is the command window, and we create variable here, and it is shown here inside the base workspace. All right. So, but what is function workspace? So functions, it does not use the base workspace, because every function has its own function workspace. Okay, so in function you cannot see where the data is being stored, or what kind of data is being stored. You cannot see directly like base workspace. So each function workspace is separated from the base workspace and all other workspace to provide the integrity of the data. So the objective of the function workspace is to protect the integrity of the data inside the function. And variables specific to a function workspace are called local variables. So inside the function, okay, if the variable is fixed or it is contained specific inside a function, we call it local variable. So after that, we will see some of the example of local variables. Okay, so the local variables are not known to other functions, other script and command window. So we cannot know. Okay, where is it? Thus, they are not shown in the MATLAB workspace window. Okay, right. So this is the function previously, right? Output poly x. Okay, but when we cannot know what are the, for example, if we let's take a look at the example first, okay, so that it is easier for you to understand. Right. So this is actually the scope of the variables. Okay, so the blue color shows the base variables, and the others shows the local variables. So the base variable, it is visible inside MATLAB workspace, but the local variable, it is not visible inside MATLAB workspace. Okay, so let's say you have a script file, okay, the main file. So any variable that you initialize within the script file, we call it base variable. Okay, or any variable that you initialize in other script file, we initialize it as base variables. Okay, right. So if you have a local function and you initialize a variable inside local function, it is actually local variables where you cannot see the variables. Right, so that is a function, a local function inside script file. But what if you initialize a variable inside a function file? So if you initialize a variable inside function files, as you can see here, it is also initialized as local variables, where you cannot see where the variable is located. Okay, so that is the scope of the variable in MATLAB. Right, next let's take a look at the example of different workspace. Right, so for example, you have a function that is, the name of output is results, your function name is distance, the input is t. Okay, so your output will return result equals to 1 over 2 multiplied by g multiplied by t, and then the power of 2. Okay, but when you run this, okay, it will show undefined function of variable g. Okay, so because g needs to be defined inside function distance. Okay, not in the command window, because function distance has a different workspace. Right, okay, let's do this example. Okay, we create a new function. So function result equals to distance t. Okay, and then result equals to 1 over 2 multiplied by g multiplied by t, the power of 2. Okay, all right, and then you rename your function as distance, right? Okay, so when you wanted to call a variable, for example, okay, g, you initialize, let me clear it all, clear all first, clear all. Okay, right, so when you initialize, what do we call the when you initialize the what you call the global variable, okay, g equals to 9.8, okay, t equals to 0 to 0 with the interval of 0.1 until 1, which is the time, okay, and then you call initial variable a and you call function distance t. You will get the error as unrecognized function because g is initialized not inside the function, okay, because in function it can only detect either the input or the local variable. So what you should do is you need to initialize it here. G equals to 9.81, okay, when you initialize it, you save, and then you run again, you will get the answer. Okay, so that is different workspace means. All right. Okay, next is passing arguments. Right, so let's take a look at example 14, where you have a function, okay, your main function called myStats with the output of average and medians when you have the input of x, okay, and this is the main function and this is the local functions, right? Right, so in these functions, the argument that you pass is, let's take a look at the second part, okay. So when you call those functions, for example, you initialize a variable called data equals to random integer from 100 to 200, okay, and then you initialize output of a and b and you call it myStatsData. So the passing argument in this variable scope is data is a base workspace variable, okay, so the data is initialized as workspace variable because you initialize inside a script. So it is passed to the myStats function through its input argument x, okay. So you initialize a variable called data and you pass this variable to input of the function here, okay. Right, so the result of the mean and median are then passed back to the myStat function through output arguments a and m respectively. So lastly, the average and median variables are passed back to the base workspace into a and b respectively, okay. So that is passing argument. Right, so in your function, you receive one input, okay. So where do you get the input? You get the input from a base workspace variable that you pass it to the function when you call it, okay. You initialize a base workspace and you initialize it as the input of the function myStats. So myStat receive the input from the data name here, all right, it receive here, and then it will calculate the median and mean, all right, and it will return back in terms of a and b, okay. Right, so that is passing argument where you initialize a variable in base workspace and you pass it to your function, and function will process all of the data and it will return back with the result that you want, which is a and b, okay, where a represent the mean and b represent the median, okay. So that is passing argument in variable scope. All right, so the next one is nested function scope. So let's take a look at example 15, okay. So in this example, we initialize a function called myCircle, okay, with the input of d and output of circumference and area, okay. As I said to you, right, if it is nested, you must have AND, okay. So inside and before we end our parent function, you must have another function inside, okay, so that we can call it a nested, right. So parent variable r and d, okay, this is r that calculated based on d you get from the input of the function, are accessible to the nested function, okay. So your nested function here, you can access the value of the parent variable that has been initialized inside your parent function, okay. So we call it like a child function lah inside here. So this is a child, so child can call the variable that has been initialized in parent function, okay. So variable still remain local at both of the nested function because it is not used by the parent function. But the variable that is initialized inside a children function or in the local function here, it cannot be initialized or it cannot be accessed by parent function. Okay, the variable initialized by parent function can be called by local function. But if we initialize a variable inside local function, you cannot call it inside the parent function. Okay, right? Okay, next we take a look at the command. Right, so what is actually MATLAB command? So command is a function that alters the environment but does not return any result. So the syntax for the command is actually the function name, input, or any other commands that are available. Okay, so input if exit can only be string. Thus command is generally a function that takes string arguments. So basically a command is actually a function, it will take only a string arguments. Okay, so the example of the command is, for example, clear, who, save, exist. Okay, as example that I showed it to you just now, if you wanted to clear the command window, you can just do CLC. So that is command. And if you wanted to clear workspace here, you can do it, clear all. So that is actually a command, the example of command, right? So since command is a function, then a new command can be created by using mfile, similar to how a function is created. Okay, so because command is actually a function, so a new command, you can create your own command by using mfile, which is similar to how a function is created. Okay, so you can create your own command. All right. Okay, so next is the last part of today's lesson, which is related to the toolbox. Right. So what is actually a toolbox? So in MATLAB, a toolbox is a collection of the followings into one package. So for example, if you have multiple functions, if you have multiple objects, if you have simulating blocks, example, documentation, you can compile it and you can call it a toolbox. Okay, so toolbox is a collection of the followings into one package. You can combine it, compile it, and you can make it into one package. MATLAB function, system object, simulating blocks, example, documentation, data, and apps. Okay. And then toolbox can be added onto the MATLAB from three sources. Okay, you can add toolbox. You can add the MATLAB toolbox from three sources. The first one is the MathWork toolbox, which is the official one. The second one is the community toolbox. So when you Google, for example, I wanted to find the Vision System toolbox. Okay, you can Google and you can download and install the what you call the MATLAB user, other MATLAB user that has shared for you. Okay. Right, so the third one is the shared toolbox installation file. So sometimes some of the users already shared some MATLAB toolbox installation file, which is actually the .mltbx file. Okay, so later on when you create your own toolbox, you will create in terms of .mltbx, which is MATLAB toolbox. Okay, right, so how you wanted to create your own toolbox? So when you have created a set of functions, you can manage them by either you can group them into a directory folder and add them into a MATLAB search bar. So if you have created a set of functions, you can group it and you can put it into one folder. Okay, and then you can package the function into MATLAB toolbox, which gives you the .mltbx file. Right, so it is an installation file of the toolbox. Okay, and then the .mltbx can be easily shared by typical file sharing methods. So you can share it by using WhatsApp, you can share it by using Google Drive, and you can share it in any means that are available. Okay, and you can also upload the file to the MATLAB Central File Exchange, while other users can download your toolbox from within MATLAB. So in addition to that, you can create your profile in MATLAB Central File Exchange, and you can share it, and you can share your findings inside or your toolbox inside MATLAB Central File Exchange, so that other people can get can use your tools or your toolbox. All right. So to create a toolbox installation file, in the environment section of the home tab, select package toolbox from the add-ons menu. In the package a toolbox dialog box, click the plus button, fill in all of the required information and click tick and to package and to finish the process. Right, so right now I will show you. Okay, right, so here I already create a folder called simple mathematics, where I have 1, 2, 3, 4. I have 4 function here: add, divide, minus, and multiply. Right, and then to create your own toolbox, okay, you need to go to home. Okay, you goes to the add-ons here. Right, so add-ons, you can have package apps, you can get add-ons, you can get your other toolbox, you can manage your toolbox, and you can get hardware support package. So this is related to the hardware lah. If you use hardware, you need to click here. Okay, if you don't have any support from your hardware, or you haven't installed any support for your hardware. Okay, so this step I will show you how you want to create a toolbox. You go to the add-ons, you click at the package toolbox, and then you can see this windows. And then what you need to do is you need to click new. Okay, and then you need to add toolbox folder if you already have if you already initialize it into a folder. Okay, you can add, and then you need to select your folder. So the one that I've been created is simple mathematics, where I have several functions. Select the folder. Okay, and then you can see here that toolbox file and folders, we have add function, divide function, minus function, and multiply function. So if you have multiple function and you wanted to compile it, you can do it inside the MATLAB toolbox. Right, so this is the name of your toolbox 1.0, and your name, Muhammad. For example, I put my name, an email, company, and you can put summary of your toolbox and the description of your toolbox, and you can also select the image of your toolbox. Okay, and then if it doesn't have, right, so you can also release the compatibility from any version available here, only the version that is available here. Okay, so if your MATLAB is R2013, you can use this release. Okay, or you can just put it all MATLAB release. Right, so after you have been confirmed to create this toolbox, there is no other specification that you can that you wanted to modify. You can just click at the tick, the green tick here, which is package the toolbox. Right, for example, I wanted to put it in the desktop. The name is simple mathematics. You click save, and you can open the output folder. Okay, so which is here. So as you can see here, you are already creating a toolbox which its name is simplemathematics.mltbx. So you can share it with other people, and when other people install this toolbox, they can use all of the function or all of the files that you have shared in the toolbox that you have been created. Okay, so this is how you can create a toolbox inside MATLAB. Okay, all right. So I think that is all for our lesson today. All right. So thank you very much for your cooperation, and I hope that you will be able to grab the knowledge for MATLAB function and how you wanted to create a MATLAB toolbox. Okay. So if you have any questions, you can just ask me in WhatsApp, or you can just ask me in Telegram, and I will answer your question accordingly. Right. Okay, guys. Thank you very much for your cooperation during this class. So I hope that we will meet again next week, all right, with our next chapter. All right. Assalamualaikum warahmatullahi wabarakatuh, and have a good day, everyone.